So number one on the homework asks, what shape do we get if we take a disk? Remember, this disk is filled in. And we make the identification according to the word, or according to A inverse. We do this one similar to how we did the projective plane. If you only make it from a disk, what we want to do is keep the boundary fixed and push down this interior part, and you get a shape like this. In other words, you get like a ball, but with a top piece cut out. Now, if you identify this edge with this edge, according to these directions, it's like zipping it up. So what shape will you get if you zip up along here? It's a very familiar one. Okay, I think we talked about the first parts of 4 in class. The main difficulty comes with doing 4D. And what you need to do is draw a hexagon. And we're going to glue the edges together according to the scheme A, B, C. A inverse, B inverse, C inverse. That is, we have an A, we have a B, a C, and then an A in the other direction. An A, excuse me, that is B, and then a C. Now, what your book tells you to do, I'm going to go ahead and erase this to make a little bit more room. What the book suggests you do is draw a certain diagonal line and then cut and then repaste. I'm going to give you a hint that's a little bit different from the one in the book, but I think a lot more straightforward. What we're going to do is draw 2 lines between the vertices. We're going to draw this one. We're going to call this one D. And then we're going to draw this one and call this one E. So what I'd like you to do when you work this problem is to first cut along D and glue the A edges. Okay, and that'll give you another hexagon. So then number 2, or step 2, redraw into a hexagon shape. Doing the cutting and gluing from part 1, it'll give you a shape with 6 sides, and this part 2 just says redraw it so it's a more regular looking hexagon. Okay, what you'll end up with after part 2 is a hexagon with the gluing scheme D, C, or the labeling scheme, I'm sorry, D, C, B, D inverse, B inverse, and C inverse. Okay, that's what you'll get once you glue it back together. D, C, B, D inverse, B inverse, C inverse. I'm not drawing the pictures out for you because this is a hint. I think you can manage that. And then step 3, I want you to cut along E and then glue the, let's see what I want you to glue. Then I want you to glue the C edges. Okay. And that should give you something with the scheme D, C, B inverse, B, D inverse, E inverse. So that is D, so I think I made a mistake. This right here should be an E. So yes, DE, B inverse B, D inverse E. And once you do that, you'll be able to, just go to a new page. Once you do that, you'll be able to collapse. This is step 4, by the way. You'll collapse the B and B inverse edges. Okay. So then what shape or what surface is the result? Now, when I say you're going to collapse the edges, what's going to happen is this is the idea. If I have something like this, and this can have any labeling scheme that I want it to have, but if this is a B and this is a B, then when I make my gluing, when I glue these two edges together, okay, they're just going to kind of get folded in and glued along. So it'll look something like this. I'll just have, let me label these other ones. I'll call this A, C, D. The result when I glue the B edges will be something like this. I have my A, my C, my D, and here is where B would be, okay? But this doesn't, but the B's get folded together inside the surface, so they don't matter anymore in the labeling. So something like that is going to happen when you glue all the edges together in step 3. So see if you can finish it from there. Okay, on number 5, we have a triangular disc where two sides of it are given opposite orientations. So we're going to draw a picture of the dunce cap that results when these discs are glued. Well, that's easy. It's going to look like this. This piece is glued to this piece, then we're going to have something like this. So this bottom edge will just become a little circle down here, or a simple closed curve, rather. And then where we glued these A's together would be right here, A. And then the second part of it says, what happens if we start out with a triangle that's identified like this? So we have A inverse, and then we want to make this one A. Well, if we glue those left and right edges, we'll have this. So here's A. And then when we made that identification, this simple closed curve now is labeled A all the way around. So what this question is saying, what will we get if we glue this simple closed curve along this edge? So why don't you draw a couple pictures and try to see what you would get if you glue those together. So in number 6, we have that radial homomorphism between the open disk X and this is Y, that open disk in the plane that has radius 1, and this is homeomorphic to all of R2. Okay, So let's draw R2 as the plane so we can get an idea of what's going to happen. So we have all of R2. And it's that radial stretching homomorphism that we've been talking about, where this all gets stretched out radially. So part A of number 6 says, what do some curves in the disk correspond to parallel lines in the plane? Well, remember, we said that a point that's really, really close to the boundary gets stretched out the most over here in R2. It gets stretched out to infinity. And a point that's really close to the center doesn't get stretched much at all. And the center actually doesn't move. So if we keep that in mind, what would parallel lines look like? Well, just for simplicity, let's take a line that passes through 0, 0. Okay? And this is open, and this is open. Because this is an open disk, we can't actually get there. Now, in the plane, we would have this line and a line parallel to it. Okay? So now, up here, these lines are further from the center. Rather, these points are further from the center than these points. So they're going to get stretched out more along radial lines. And this one's pretty close. It won't get stretched out as much. So what this is going to look like will be something like this. Then if we had another parallel line up here, it would look like this. And if we had another parallel line, say down here, it would look like this. Okay, so these lines are all parallel on the disk because they never intersect. Okay, so this line is parallel to this line, it's parallel to this line, it's parallel to this line. This is a family of parallel lines on the disk. Now, part B of number 6 says that each direction in R2 corresponds to a family of parallel lines. That means any direction I take from the origin, this line corresponds to a whole family of parallel lines. Okay. So this family, it's all the same family because they're all parallel to the origin. Excuse me, to this pink line that passes through the origin. Okay. So let me move this up here. Now what we're asked to do in 6 is we're going to adjoin a point at infinity. Okay. So we're going to imagine that there actually is an infinity around R2. Normally we don't think of infinity as a point, but we're going to adjoin a point at infinity that we're going to call infinity for each of these parallel lines. So this pink line is going to eventually get to a point at infinity on this side and on this side. Now we imagine the point that it arrives at as being the same point as this one. So this is an identification. Okay? And say this blue line is going to get here. We imagine this point at infinity gets identified with this point at infinity. Okay? So think about what this is going to look like, what this boundary of infinity would look like if we use the homeomorphism that turns R2 into the open disk. into the open disk. What is this point of it at infinity going to correspond to? That's 6b. And then to do 6c, just remember that this point is identified with this point with this point. So we're going to have a bunch of these opposite points being identified. So think about, here's the hint for 6c. This was our labeling scheme for the projective plane. Okay, figure out how, when we use the homeomorphism to turn this into the open disk, and figure out what this boundary point at infinity turns into, how is the result going to be like the projective plane?